I will introduce about I will introduce about about the technology in applied materials. Because I went to applied materials seminar 2 days seminar 2 days ago. So I could run from the seminar, and I recorded the seminar contents and I organized it. So I present the seminar content today. Originally I want to deliver all parts in or contents in the seminar, but in the process of organizing, I couldn't organize or contents during 1 hour. So I just say about the metal wiring connect. Before that we need to know the structure of semiconductor. So I will I will look for MOSFET. This is a MOSFET called semiconductor. And semiconductor, as I said before, semiconductor is a device to turn on or turn off. So when gate voltage is high, then it is turned on, and gate voltage is low, then it is turned off. To in the detail. We need some. How can I turn off? Yeah. So we need to apply some voltages in these three. Yeah, we need to apply these three terminal in MOSFET. So we need to apply some voltages in these three terminal. Usually drain is high voltage and gate is high voltage, and source voltage is ground normally. Then we need to apply some voltages to gate and drain. To apply voltage, we need to connect with metal line, because voltage is a potential about electrical signal. So we need to deliver the electrical signal, and electrical signal is delivered in the metal line. So we need to connect gate and drain. We need to build metal into gate and drain. Yeah, it's the structure. It's the structure in MOSFET. I couldn't understand the or things, but but they say it is global interconnect. So this yellow line is metal line, and it is connected in, and it applies the drain voltage and gate voltage. And there are a lot of layers in chip. So one first layer is metal 1, second layer is metal 2, third layer is metal 3. So metal interconnection in semiconductor industry is a very important thing. Is very important. Is very important thing. It shows the importance. So we need to fill the metal. We need to fill the metal in the MOSFET. But there are some problems. Uh, but there are some problems in the it's my process. It's my process about it's my process. It's my process during posting a blog. Uh, Originally, we can see the charts. Uh, before that we need to know the concept of resistance. This big letter is R. Big letter is R, and R means resistance. So resistance is low times L over A. So it is proportional to low. Low is resistivities, and I said about it. Resistance is the opposite concept with with the connection, because resistance mean resist the current flow. So resistance is a interruption is inter is obstacle of flowing current. So it is not good for metal line, because metal line lowers the connection between metal line is for interconnection. So resistance is not good for metal line. Then we could see the resistivity. Resistance is proportional to resistivity. So I just say resistivity is just resistance for not for not for not for not for friends who are not majoring in this field. So resistance is resistivity. So we can see Cooper has a very lower resistivity. So the lower resistivity mean good interconnection in metal lines. So Cooper is used for metal interconnection. But Cooper's mean free fast is very long. Mean free fast is very long. Mean free fast mean there are uh, yes, the in atoms there in a material there are a lot of atoms. So, if and if and mean free fast mean electrons move with this cursor, but it collides with atoms. It collides with atoms. Atoms there are many atoms in one material, so it has very limited mean free path. Mean free path it mean it doesn't call it the path that it doesn't call it the path that it doesn't call it. So if Cooper's mean free path is 39 nanometer, then it doesn't call it grid, it doesn't call it atoms in the material for 39 nanometer. So it is very wrong. It's the reason why Cooper has low resistivity, but it is not good in nanoscale because in real industry in modern industry the high aspect ratio concept is very important. Aspect ratio in MOSFET semiconductor. Yeah, we have a very limited area, so we need to make Tor devices, because for example we have a very high we have a skyscraper. We have a skyscraper because we have a limited rent, so we make a skyscraper. It is the same in semiconductor industry too. We need to we need to make devices with a high aspect ratio. As we said, as we can see, the width is very very shorter than but depth is very wrong. It is high aspect ratio personality. So if width is very if width is very short, then electrons then Cooper's mean free path is 39 nanometer. Then Cooper moves from this point and to this point without collision for 39 nanometer. But if the pitch is just 10 nanometer, and if the distance is just 10 nanometer, and mean free path is 39 nanometer. It moves 10 nanometer freely, and it collides with this sideward. It is called sideward scattering. Then 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 yeah then it then it then the momentum disappears from the collision, so it degrades the it degrades the electrical property. So but even though the pitch is 10 nanometer, even though the pitch is 10 nanometer, if the mean free path is just 10 nanometer, then it moves really just 10 nanometer, and it doesn't the momentum doesn't disappear, so it is good for electrical property. In this reason we don't use only Cooper, even though the Cooper's resistivity is very low, so we use other materials. So they said the materials in the Atom 2026, and I'll say about it. They said the three materials: cobalt and ruthenium and molybdenum. Yeah, molybdenum. Their mean prepass is 10 nanometer and 6 nanometer and 8 nanometer. So it is very lower than Cooper's mean prepass. So it is good. So it is good for yeah. So it is good for lower. It is good for shorter pitch for modern semiconductor industry. So modern semiconductor industry. So these materials are used for modern industry, and applied materials use the machine. The machine name is Endura. Yeah, the machine name is Endura, and they deposited the ruthenium cobalt. They used the double layer. They used a double layer ruthenium cobalt. Originally the double layer was as I remember TITIN or TATAN. Yeah, these double layer was used, but from their researches, cobalt, ruthenium, and molybdenum has very lower mean free path, so it can have good resistivity in shorter pitch. So they developed the ruthenium cobalt binary liner. I'll end my presentation, and I added for I'll add two kinds of contents in Atom 2026. Okay, thank you.